Hello, my name is Marcel Chouchet, and in this video we will be solving problem 3.22 from rigid bodies equivalent force systems. The problem is given as follows. Before the trunk of the tree is felled, cables AB and BC are attached as shown. Knowing that the tension in cables AB and BC are 555 newtons and 660 newtons respectively, determine the moment about O of the resultant force exerted on the tree by the cables at B. We are given the tension along AB to be 555 newtons and that along BC to be 660 newtons. Ultimately, our goal is to find the moment about point O from the resultant force exerted on B. In order to do so, we will need a distance vector pointing from O to B and cross that with the resultant force vector. We must first recognize force direction. As we know, the ropes can only pull. Thus, the force must be directed from B to C and B to A. The tension can now be defined in terms of the force vectors as the magnitude of the force from B to A and the magnitude of the force from B to C. Reading the diagram, we obtain the following points. In order to obtain the resultant force vectors, we must first obtain the force along B to A and that from B to C. The vector force from B to A is given by this equation. We are given the magnitude of the force, however, we will need a unit vector to determine the direction. We can obtain this unit vector through a distance vector pointing from B to A and the magnitude of that distance vector from B to A. Utilizing the points previously obtained, subtracting A from B, we obtain the points as follows. Through vector notation, we are given negative 0.75 meters in the I-hat direction and negative 7 in the J-hat, as well as 6 in the K-hat. Once we have obtained the unit vector, we can now multiply the unit vector with the magnitude of the force to obtain the force vector. The force vector along VA is thus given by negative 45 newtons in the I-hat direction, negative 420 newtons in the J-hat, and 360 newtons in the K-hat. We now find the force along BC through a similar method. Again, the vector is obtained by subtracting point C from point B. Multiplying the magnitude by the unit vector, we now obtain the force vector from B to C as 340 newtons in the I-hat direction and negative 560 newtons in the J-hat direction, as well as 80 newtons in the K-hat. The resultant force is now given by the sum of the force from B to C and the force from B to A. Now we can find the moment about point O. But first, we must find a distance vector from O to B. As indicated by the figure, that is 7 meters in the J-hat direction. Doing the cross product, we obtain the moment about point O as follows. Where J crossed with I gives us a negative K-hat direction, and J crossed with K gives us a positive I-hat direction, and J crossed with J gives us a 0. The answer is thus 3,080 Newton meters in the I-hat direction and 2,070 Newton meters in the K-hat direction. Thank you.